Hi everybody, welcome to the demonstration of pattern recognition course project for Dr. Wu. I am Sumaiya Shomaji. Today I am going to show the implementation of a CNN based facial recognition system. So let's get started. I would like to start with the motivation of the project first. So, from IoT application to cyber world, security is one of the fastest growing industries, and authentication is done so often for security purpose. Now, most of the authentication approaches can be categorized into two major classes, that is the non-biometric type and with biometric modalities. So the problems with the non-biometric modalities are the authentication systems are normally very weak because they are vulnerable to attacks like stealing or spoofing the templates, and also it's a hassle to remember all these passwords. But on the other side, if we think about biometric modalities, they are very advantageous because the authenticating systems are very strong, and the templates are difficult to attack because they are like physiological properties of human. So it's difficult to steal them or to spoof them. And also we don't need to remember biometric modalities. So definitely this is better than the other traditional password based modalities. Now, there are many types of biometric modalities, for example, face, iris, fingerprint, etc. So, for this project, we have chosen a face recognition system. Now, the question is why face? The reason why I chose face was three. Firstly, it's the widely used biometric modality for systems, and it's very easy to collect face datasets. I mean the face templates, and also faces have always shown very promising results after iris during authentication. And why CNN is considered for the project? So CNN is able to provide very high accuracy, and a big challenge with any biometric database is it is very large, and it has noisy data. So both of the challenges can be easily handled by CNN. That's why I have chosen my topic for this project is face recognition system with CNN application. CNN means convolutional neural network. It is a type of neural network which is used for classification, and here the input is always image. So there are mainly four building blocks or layers in CNN. So the first one is input layer. So the input layer, uh, we normally provide the input image, and during convolutional layer we import some filters, and then we do convolution between the filters and the input image. In the pooling layer, the size is normally reduced, what we got from the last layer, and the fully connected layer, the classification is done by establishing a connection between the results from last layer to directly the classes we have assigned. Now we are going now there are some relevant studies which have performed face recognition, but with different approaches. So I'm going to show the comparison between deep learning or CNN based method with others. So let's start with the first one, which is nearest neighbor search. It is very easy to implement. That's why it takes very low time also for performing, but the accuracy is medium in this case, and it does not provide any security to the template. And when we use PCA or kernel PCA, the accuracy is medium to high depending on how we are implementing. The time consumption for this method is not too low or too high. I would say it's medium. And can we apply it to large data sets? The answer is a big no, we can't do that. And it does not directly provide security to the template, but still it depends. Like if anybody is using only the eigen features or vectors and storing those as templates of some people uh, instead of saving the raw features, then it can provide some security. So in same way we can add a little bit of security to the templates if we use LPP and LDA. There are also some other techniques through which we can do face recognition. Both of them are having medium to high accuracy, but the time required for performing during LBP is pretty high because the Gabor filters are large and it takes a time to extract Gabor based filters. uh, LDA takes medium amount of time, and again they sometimes show good results to large database, but in many of the cases they just fail. That is the reason why CNN or my proposed approach is better than theirs, because it provides very high accuracy, and it is applicable to large data set. The data set can be noisy too, which normally happens in any biometric data set. It can still provide a good result in spite of having noise in the data set. And also it can provide security because the raw data set goes through a lot of transformation and mapping, so it's very difficult to get back to the raw template and manipulate them by an attacker. Only problem with with deep learning method is it takes high time to perform the training, but once the model is trained, it's good. We just have to use the same model to do classification or testing, so it's just a one time problem when we do the training, but in rest of the cases it is very good.